Again, we look at problem number one, but this time we work it with dimensional analysis. A client is a client with cardiogenic shock weighs 220 pounds and is receiving dopamine at the rate of 3 micrograms per kilogram per minute. The solution strength available is dopamine 400 milligrams in 250 milliliters of D5W. The nurse should set the infusion pump to deliver how many milliliters per hour? I'm going to leave what we did on the last problem on the board so you can look at the previous video. And we worked it with we worked it with ratio and proportion. This time we will do dimensional analysis. The main thing we need to realize is that we need to multiply the given rate, and from the last video we realized that this is that 3 micrograms per kilogram time per minute is 3 micrograms times kilograms, 3 micrograms per kilogram times minutes. Now we need to convert that. So let's multiply that times some conversion factors. Okay, and we'll get that in a second. And so we have a couple conversion factors that we need. But all we're doing is we're looking at our given rate. That's what I wrote first. And then it's an amount of medicine. So I need to compare that amount of medicine that's running in that rate to my total medicine, which is the 400 milligrams. And then I'm going to multiply that by some conversion factors because we're going to have to get all of our units into the same thing. And then I need to multiply that amount by the vehicle that carries the medicine. So that's going to be my volume. So remember, it's my rate compared to how much medicine I have available. So this is my rate compared to how much medicine I have available times the vehicle that medicine is coming in, and that's in milliliters. Now I need to also multiply it by a weight because that is an amount of medicine per unit of weight. So if I multiply by all the weight, I get the total medicine. And so that's why I'm going to put this here. But I need to multiply that by a conversion factor in order to get the pounds to be the same as the kilograms. Okay, so now we know that this is over 1. And so now you can see that all we have to do is just remember to think of our problem. Remember, it's a rate. This is our order. This is our ordered rate. And this is our total medicine available, or this is our available medicine. Let's put available. All right. And this is our vehicle that the medicine comes in. And this is the weight that we have to multiply all the weight by this rate in order to get all of the medicine. Okay? And so when we do that, we first find that we have to do some converting. And in fact, I'll leave all that back up there. Okay, we find we have to do some converting because we need to get these micrograms into kilograms. Okay, so we're going to put this as such. So what I need to get these micrograms into kilograms. So I draw my micrograms on the bottom so it can cancel out, and then I'm converting it first to milligrams. And so I now have the micrograms able to cancel out, but now I need to change the milligrams to grams. So now I write the milligrams on the bottom, my grams on the top, and now my milligrams can cancel out. There are 1,000 micrograms in 1 milligram and 1,000 milligrams in 1 gram. And so now I need to change the grams to kilograms, so I write my grams on the bottom. I'm changing it to kilograms, write that on the top, and then I realize that there are 1,000 grams in 1 kilogram, and that's how I get my conversion factors. And these are all being multiplied together. Okay, now I need to change these minutes into hours. So I write my conversion factor here. So I have 60 minutes over 1 hour because I have minutes on the bottom. I write minute on the top. I'm converting to hours, so I write that in my leftover space. And then I realize that there are 60 minutes in 1 hour. Now I need to convert these milligrams into kilograms. So what I do is I realize that I have grams on the bottom. Well, I know I'm going to write milligrams first. I should have written milligrams first. And then I'm going to write grams on the bottom. And I realize that there are 1,000 milligrams in 1 gram. And I'm multiplying that by this because I need to convert the grams to kilograms. Now, how do I know where to write the grams? Because it was on the bottom. I move it to the top so it can cancel out. And I realize that there are 1,000 grams, 1 kilogram. This conversion factor allows me to have the kilograms on the bottom. And because I'm dividing, that's why the big numbers come on top, because you're dividing by something that is less than 1. But just realize that it's working out right when you get the kilogram on the bottom the same as the milligram. All right, so now I need to change these pounds to kilograms. So I write I write my pound on the bottom first to cancel out, and then I write kilogram on the top, and I write 1 kilogram is equal to 2.2 pounds. And now let's see if I'm ready to start working the problem by canceling out units. All of the canceling out units means is you're getting rid of everything you don't need to see what you have left. I have kilogram canceling with kilogram. I have microgram canceling with microgram, milligram canceling with milligram, and gram canceling with gram. I have minute canceling with minute, and I'm left with hours. I have milligrams canceling with milligram, gram canceling with gram, and then I have kilogram canceling with kilogram and pound canceling with pound. And what I have left, let's put it in purple, is milliliters per hour. And that was what I wanted my answer to be. So now all we have to do is take all these numbers on the top, 3 times 1 times 1 times 1 times 60 times 1 times 1,000 times 1,000 times 250 times 220 times 1, and multiply them together. And then we can put a 1 down here. 1 times 1,000 times 1,000 times 1,000 times 1 times 400 times 1 times 1 times 1 times 1 times 2.2. And I will calculate that for you. Okay, so let's calculate. That's 3 times 1 times 1 times 1 times 60 times 1 times 1,000 times 1,000 times 250 times 220 times 1. That gives us 9,900,000,000,000,000. And then we are going to multiply the bottom. 1 times 1,000 times 1,000 times 1,000 times 1 times 400 times 1 times 1 times 1 times 1 times 2.2. That gives us this number. 880,000,000,000,000. And now when I divide those, I get 11.25. So my answer is again 11.25, and I have milliliters on top and hour on the bottom. And that's how you work it with dimensional analysis for problem number 1.